And finally, in section 2.3, day 2, part 2, we'll do one more example of an infinite solution to figure out what's going on with the problem. So this one's all about a piggy bank. So it says Janice was given a piggy bank on her 7th birthday and put it to use immediately. Each time she puts one or more coins in the piggy bank, she keeps track of the number of coins she's collected to date and the accumulated value of her collection. She only collects nickels, dimes, and quarters. 6 months after her 7th birthday, she looked at her record and ascertained that she had collected 480 coins, which were worth $60. How many combination of coins are possible in the collection? And if she counted 100 quarters in her savings, how many nickels and dimes are in her collection? So it's a slightly different twist on part A. So let's define our variables again. So I'm going to let X equal the number of nickels in her collection. I'm going to let Y equal the number of dimes. And we'll let Z equal the number of quarters. So we know that she's got 480 coins altogether. So X plus Y plus Z equals 180. We also know that she's worth $60. So I'm going to choose to, instead of write them in terms of dollars, put them in terms of pennies so I don't have to deal with those decimals. So each nickel is worth 5 pennies, each dime is worth 10 pennies, and each quarter is worth 25 pennies. So the $60 becomes 6,000 pennies. Now we need to go solve the system. Let's write it as our augmented matrix. So when we write it as our matrix, we will have what 1, 1, 1, 480. We'll have 5, 10, 25, and 6,000. Let's go ahead and row reduce this one. I know I didn't on the last one, but let's go ahead and row reduce this one just for practice. So we have our 1, we needed 0. So we're going to do row 2 minus 5 times row 1. We'll have a 1, 1, 1, 480. 5 minus 5 is 0. 10 minus 5 is 5. 25 minus 5 is 20. 6,000 minus whatever 5 times 480 is. I don't know that one. So 6,000 minus 5 times 480 comes out to be 3,600. Okay, so there's our first step. So our first column is our unit column. That's good to go. Let's go ahead and move on to the next column. We need a 1 where the 5 is. So we're going to do 1/5 of row 2. So we have our 1, 1, 1, 480. We'll have 0, 1, 20 divided by 5 is 4. 3,600 divided by 5 is 720. Now we need the 0 in this spot. So we're going to come in and just simply take row 1 minus row 2. So we'll have a 1, 1 minus 1, 1 minus 4, 480 minus 720 is a negative 240, and we have our 0, 1, 4, 720. And we're done with our row reducing. So that worked out pretty quickly. The numbers were nice. Okay, so what do we have? Well, we have possible solutions here. So we're going to write this in terms of parameters. So we're going to come in and let Z equal T. Then from the top row, we know that X minus 3T is equal to a negative 240, or that X is 3T plus 240. From the bottom row, we know that Y plus 4T is equal to 720, or that Y is equal to 720 minus 4T. So we have our T, we have our 3T plus 240, and we have 720 minus 4T. The question, though, is not asking for possible formulas or solutions. What it wants to know is how many combinations of nickels, dimes, and quarters can she possibly have? What they're asking us is how many different values can T take on? Can I randomly just pick a value for T, or is there a range of values for T? So the number of combinations is basically the values, the different values T can be? Well, we know we can't have a negative count on the number of coins. So what I'm going to do is take each of my formulas for X's and Y's and set them equal to 0 to make sure we don't end up with a negative number of nickels or a negative number of dimes. So we're going to set 3T plus 240 equal to 0. And it looks like I messed up. Sorry, I just caught that. And how I knew it is because that was going to give me a negative number. This is a negative 240. Sorry. We moved the 3T, but not the 240. So back over here, we have 3T minus 240. So then 3T equals 240, and T is equal to 80. So in order to have no nickels, we would have to plug in 80 quarters, and then we would have no room left over money-wise or coin-wise to have any. We'll do the same thing with the Y values. So we're going to take 720 minus 14 and set that equal to 0. 720 is equal to 4T, and T is 720 divided by 4, which is 180. So basically, we're saying that T has to be bigger than 80, but less than 180. So we're going to write a statement that T is less than or equal to T. I'm sorry, 80 is less than or equal to T, which is less than or equal to 180. But notice it could be equal to both of those. If it were equal to 80, then you would have no nickels. And if it were equal to 180, you would have no dimes. So how many values is it taking on in between there? Well, it could be 80, 81, 82, 83, 84, 85. So I'm going to subtract the two. 180 minus 80 is 100. But then don't forget that you can include the endpoint. So that's actually 101 combinations. Because when I subtract them, I don't count the 80. So we end up with 101 different combinations in our piggy bank, which is quite a few. Now, part B on the problem says, but we know that she's got 100 quarters. So that's T. So we know that T is 100. So then how many nickels and dimes? So for the second part, they're coming in and picking a specific number of quarters. So then we can figure out the nickels and dimes. So part B, Z, which is T, is equal to 100. So then X, number of nickels, is going to be 3 times 100 minus 240. So that's 300 minus 240, which is 60 nickels. Again, that was 100 quarters. And then Y, which is down here, is 720 minus 4 times 100. So that's 720 minus 400, which comes out to be 320, and these are the dimes. So with a specific solution, you've got a specific answer. And that wraps up chapter 2. Thank you.